Hey, this is Dan from RWX. We hosted a webinar on Monday where we shipped a new platform for building Docker container images. And some people missed that webinar. They asked if we had recorded it. Unfortunately, we did, but somehow managed to configure it to only record my face and not my screen. So I'm going to record another demo here just to show you how it works. I'm going to make a new YAML definition file. Let's call it simple.yaml. And I'm going to define a base image. I'm just going to use Ubuntu 2404. Config none, I'm going to start with just a plain Ubuntu image, and I'm going to run this on ARM just because I'm going to pull the image down locally. And then I'll need a task. Right now I'm just going to no-op this and exit 0. So we're just going to have basically a vanilla Ubuntu image here. I'm going to go ahead and build the image. To do that, you just do RWX image build. Give it the YAML file. I'll target the image task. Open will open my browser automatically. And I've actually built this image before, so interestingly, this task was already cached. But if I go back to my terminal, we can see that the image was built and pulled down to my machine. So I can now go and grab this image tag here and go to the container tag, docker run it, paste that in. We'll just open bash, and there we go. I'm running the container that was built on RWX and pulled down to my machine locally. And we can see that this is indeed the Ubuntu container that we specified as our base image. So let's go ahead and do something a little more fun now. Go back to our definition file here, and let's define a script that we run. So I'm just going to cat into, let's call it script.sh, and make this a bash script. Just echo hello from an image built on RWX. So we'll write that in there. I need to chmod it. And then I'm going to echo, let's do the full path, script.sh. And I'm going to write this to RWX image command. So this is the equivalent in Docker of doing cmd. Instead on RWX, you just write to a file in this RWX image directory. T just both writes to the file and prints it to standard out. Sometimes helpful in the log so that you can see that. And let's build this image now. This time I'm going to tag it as well. I'm just going to tag it with demo just to make it a little bit faster to run it. Okay, so we can see that our image is building. We can see it printed out the script from that T command I had. Go back to my terminal, image built. So docker run demo, and that's it. We've configured the command. Hello from an image built on RWX. And RWX provides, one thing we focus on a lot is providing just a really fast feedback loop. So if I were to go back here and say hello again from an image built on RWX, I'll go ahead and build it again. I'm going to tag it. I'm just not even going to bother opening my browser this time. We'll see that that run was kicked off. The URL is there if I want to see it. The build has succeeded. It's pulling it. Docker run demo. Hello again from an image built on RWX. Not terribly exciting when it's just a simple script. Even doing this with Docker locally would have been pretty fast, but RWX has really advanced caching capabilities. It's the only CI/CD platform with content-based caching, which is similar to what Docker already does. But the big difference is that with Docker, once you have a cache miss, everything downstream is also a cache miss. Whereas with RWX, you can actually have a miss followed by a hit, which is really impactful. I'll go ahead and show just a couple other capabilities here. And maybe, actually, you know what, before I do that, let's do an example that's just a little bit more fun. Let's switch from the Ubuntu image. This is any Docker base image that you want. So we can switch to Nginx Alpine. And now for our image task, let's make an HTML file. And we'll write this into the share directory and HTML. Body h1 hello from RWX, and that's actually all we should need to do here. Is just have that file in the Nginx image. I'm gonna go ahead and build that one. We'll do HTML example. I'll open my browser. We can watch it build. Okay, I've actually given this demo as well. We can see that it was built there. That's why the task is already cached. RWX just by default, if you go to run the same command that you've run before on the same source files, it just automatically caches it. But anyway, we can go back here now and Docker run We'll need to map the port. I'll do 8080 locally to 80. And what do I call it? Oh, HTML example. And should be good. Okay, Nginx has started, so I can go back in my browser now. Localhost 8080. Forgot the L. And there we go. Hello from RWX. And again, super fast feedback loop. I can just go change this. Hello again from RWX. Rebuild it. It'll build remotely. It's building in the cloud. I've done the hello again example as well. And I think I did that exact one on the webinar. But the image is built. So, Docker run and go to my browser. And where is it? Oh, refresh. Hello again. So let me showcase a couple of the capabilities that really make building images faster on RWX. And there's a couple of these that are really impactful. The first is, I'm going to go back here and actually I'm going to switch this back to Ubuntu. The first is multi-stage builds. So in Docker, it's a little tedious to run anything in parallel inside of BuildKit. Because when you do that, you have to get the files from one task into another one. And you usually have to copy from a certain layer. Whereas with RWX, you don't have to do that. So I'm going to echo task 1. I'm just going to write this to 1.text. And I'm going to make a second task here, task 2. And update this accordingly, as well as that. And actually, you know what, one other thing. I'm just going to slow this down a little bit, just so that we can see. With RWX, these two tasks are automatically going to run in parallel. So there aren't any dependencies between them. These are two independent tasks. So when I kick this off, these two tasks are going to run in parallel. But then, as I was just saying, I can do key image. And here I'm going to use 1 and 2, and I'm going to combine these together. I don't have to copy any files specifically or anything. I can just combine them. Say, take these two parallel tasks, pull them down into a single image. And nothing really I need to run here. I'm just going to exit. But we'll pull those down into a single image task. So I'm going to do RWX build. This is still simple.yaml. Or sorry, image build, simple.yaml. I'll target the image task. We'll watch it build. So here you can see task 1 and 2 are running in parallel. And we didn't need multiple from declarations or anything. We just had two tasks that had no dependencies between them. So RWX automatically figures out the maximum parallelization for your build just based on the dependency graph in it. And we can see that those files were built, and now we have the image pulled successfully. I forgot to tag this one. And actually, you know what? It's probably fast enough just to hit this again. And I'll tag it as multi-stage. So it ran. It was cached. Already done. So I can now Docker run, interactive. I'll do the multi-stage, bin bash. And we can see that both files are here. Both 1.txt and 2.txt are present on disk. Again, without any complicated copy from semantics. And by default, RWX is running these on separate virtual machines. This is another difference from BuildKit, because with BuildKit, you typically have one beefy build box that will run things in parallel, but on that same box, so the tasks are competing for CPU resources, as well as competing against other builds that are running. So it's kind of this resource allocation problem where it's really easy to be either underutilized and over-provisioned, or under-provisioned and overutilized and get contention on your build server. Or, your container images are queuing and just going a lot slower. So I could actually take this and, because this is also automatically running across distributed virtual machines, I can also just run this on a bigger agent if I want. So I could crank this up to, let's say 4 CPUs and 16 gigabytes of memory. Default is 2 CPUs and 8 gigs. And I'm going to run nproc here just so we can see that indeed this task has 4 CPUs. And I'll go ahead and kick off another image build. Obviously, we don't need it for what we're doing here, but you could easily imagine in a normal container build wanting to crank up the CPUs for maybe a task that is compiling some code or something that's really intensive, but you don't necessarily need that for every single layer in your image. So I'll go back and build this again. I'm opening my browser so that we can see it being built. You can actually see, I think my face is in the way. There we go. You can actually see that task 1 was cached because we didn't change that. And task 2, you can see the 4 here printed out. So this indeed did run on 4 CPUs. Interestingly, the image task was also cached because even though an upstream task ran and task 2 had to run again, image was the same. It was the same command on the same files that it had already previously run, so it did not need to re-execute. And we can go back and we can see, here that the image was built. If I wanted to, I can docker run, multi-stage bin bash again, and we can see the files that we created. So you get this automatic graph-based parallelization based on the dependencies that you just define inside your image. And you don't really need to think about optimal parallelization at all. The other really big benefit of building container images on RWX is the automatic content-based caching and the fact that you can have a cache miss followed by a cache hit. So you can imagine, I'm going to do like a fake code task here, and I'll make a couple directories. And let's say this repo, or we have some project that maybe has module A and module B, echo code in module A. We'll write that to like module A code.txt. Obviously a very contrived example here. And then I'll switch this, we'll make a corresponding file code in module B. And, we could automatically run this in parallel. So we'll say compile module A. And since this is just a fake example, I'm just going to cat this file. But then the thing I can do here is I can filter this task down. And I can say filter this to only module A. This is really important for caching. When you filter inside of RWX, only the files you specify will be present on disk, and therefore only those files, only the contents of those files will affect the cache key. So this is kind of different. You've probably worked with other CI platforms where you do hash files, and you kind of manually come up with a hash key based on the contents of certain files. But on other platforms, when you do that, there are other files still present on disk that can affect the execution of that command, which means you can very often get false positives where you're getting cache hits and you shouldn't. Somebody has to go and they have to bump the cache, or they have to have a version identifier in their cache key and go in there and bump it from V7 to V8. With RWX, you don't have to worry about that. You will never get a false positive on a cache hit because only the files you specify in the filter will be present on disk. And actually, I'll just update this task real quick to show that. We'll just print all the files in the directory. So then we could do something corresponding here for module B. And we'll update that. We'll update that filter. And then image, we'll just pull together compile module A and compile module B. Nothing really happening there, but we'll target this task. So let me go ahead and run this and build another image. So we can see these two are running in parallel, module A and module B. I did something wrong. I forgot to use the code. So you don't specify the dependency. It was just running without that. I'm going to kick it off again. Super fast feedback loop, just being able to iterate, even though it's running on cloud infrastructure, being able to use the local CLI like this. So we can see that these ran, but as I described, there's that find command at the top of our task, that find dot. So you can see that with that filter that we had, only module A was actually present, and when we compiled module B, only module B was actually present. And I actually should have, let me change this. I'll just do another find there. We'll run one more of these, and we'll be able to see that both files are present when we combine them together. So with this, the real fun part of the demo is if I go back here and I say change the code in module A, code is at the top of our dependency graph. Both of these are downstream from code. But unlike Docker, where once you have a cache miss, you always have a cache miss, with RWX that is not the case. So if I kick off the build again here, code is running because we just changed that code, and compile module A is running, but compile module B was actually a cache hit. So it did not need to execute at all, because even though code was upstream of it and changed, compile B was still running the same commands on the same files as it had previously executed. One other really interesting part of RWX is that this is actually the way our CI platform works. We can build container images so fast that we actually build one between every single step in a CI pipeline. Every single step has its own container image associated to it. And we have ways that you can view that. So actually I can view the task. I can see the entire file system here. And we actually have a button where we can click in and you can actually see the files that are present. So it's kind of like Dive, if anybody's used that tool for looking at container images and expecting it. And I can also go over to this diagnostics tab, and here's the container image. There's actually a command that I can just pull this image directly. So this is like just the code task upstream. It's not that whole image where we fake compiled some code, but I can click this, copy that to my clipboard, go back to my terminal, RWX image pull, and I can pull it down. And then, of course, if I want, just grab this and docker run, paste that in, bin bash, and we can see see our files there. So we automatically get a container image for every single task, and this happens with the tooling that I'm demonstrating here, where I'm doing this RWX image build. But this also happens on our CI platform. When you do a run, there is a container image built that corresponds to every single task in the entire CI run. So if you need to debug something, we offer a lot of great tools for debugging. We actually have a breakpoint feature that makes it really easy. I can just show you how that works really quickly. But you can also just pull down the image, if it's something that you want to run locally. But to use a breakpoint, you just set it like this, RWX breakpoint. So I can RWX run, we just changed that syntax recently. RWX run, I'll just target the code task for this one. I'll do open so we can see it. Code task is running. We can see it's debugged. Task can carry a breakpoint. Copy this to our clipboard, paste it in. And in this case, I'm not running the container locally since I set that breakpoint. This is actually running on a remote cloud instance, but I'm connected to it that quickly, so I can now go and debug. So a couple different options with RWX. If you want, you can take that container image and pull it down to your local machine, but also just very fast to fix issues inside of a pipeline by being able to set one of these breakpoints and connect to it remotely. So that's it. I'm always happy to chat with people. We're helping a lot of engineering teams speed up their pipelines, be able to ship code faster, get code into production faster by building container images a lot faster than what's happening with existing tools today. I highlight a couple of the caching benefits I was getting, and the really interesting part of that is that it's all happening effectively based on the entire registry of everything that we've ever built. So unlike other Docker type pipelines, and where you might be pulling an image and doing cache from and cache to, you don't have to do anything like that. I was getting all of those caching benefits just from RWX image build because we're doing this automatic content-based caching where we look at everything we've ever executed and the cache keys that we have for it within the retention period, of course, and then we can just automatically produce those cache hits without any sort of complex cache configuration. Happy to talk with anybody who wants to learn more about this. My email address is dan@RWX. Thanks.